Hello students. Hello students. We are back to chapter 3 of this course, Networking Essential Management. And in chapter 3, this chapter is still on the physical layer cabling. You remember in chapter 2 it was also physical layer cabling, but we were looking at the twisted pair cabling. So in chapter 3, inside the physical layer cabling, we're going to look at the fiber optics. We're going to look at the fiber optics. Okay, without much ado, let's begin. Now this chapter, here are table of contents. The things that we're going to do, we're going to look at the introduction, the introductory part in 3.1. Remember, this chapter is always divided into several segments. Each segment has its own PowerPoint. So from 3.1 to 3.7, we're going to have several different lectures in this chapter as well, just like we had in chapter 1 and chapter 2. So we're still going to have several different lectures on chapter 1. Okay, so the chapter 1 part 1, this is how we segment this course. Chapter 1 part 1 talks about the introductory aspect of cable, optical fiber cable. Chapter 1 part 2 talks about the nature of light. Chapter 1 part 3 we talk about fiber attenuation and dispersion. Okay, chapter 1.4 we talk about the optical components, fiber connectors or connections and splices, what you use for the networking. Chapter 3, not chapter 1. Chapter 3.5 we talk about the optical networking architectures and optical Ethernet, both in our campuses, the issues we have in campus buildings, and the backbone, the telecommunication closets that is designated to provide the network for campus area. Then chapter 3.6 we're going to talk about safety, and chapter 3.7 we're going to talk about troubleshooting fiber optics. Okay, so this is how we're going to run through them, like as I've mentioned, and then let's take a look at the objectives, what we're going to learn in this first case. Let's take this one a bit away from this. Okay, the objective, what we're going to learn in this case will be, first of all, we're going to describe the advantages of glass fiber over the copper connectors, the copper cable, the twisted copper cables that we learned in chapter 2. We're going to find the advantages that the glass fiber, the optical fiber cable have over the copper cable. That's the first objective. The second objective, what we're going to learn in this course, is we describe the differences in how light travels in a single, and how light also travel in a multi-mode fiber. Okay, the third objective is to look at attenuation. We have to know the meaning of attenuation and dispersion in fiber optics cabling. We have to know the meaning, their differences, and their applications. And then we have to know and be able to describe the components of optical fiber system. Okay, we have to be able to describe the component, the fiber system itself, the optical fiber system itself, from the source of the light to the optical fiber itself, and then to the receiver end and the connectors that are used in between. Okay, then we have to be able to describe the issues of optical networking, which includes the fiber to the business and the fiber to our home. Okay, so these are some of the objectives for this course, and also we also have to look at or describe the new networking development associated with optical Ethernet. We also have to calculate a complete power budget analysis for a fiber optics system. And then we have to understand the safety issues when working with fiber optics. So these are the objectives of the whole program of this chapter. Okay, now let's take a look at the first one, which is 3.1 introduction, or the 3.0. They actually have 3.0, but this one, it was combined with 3.1, the introduction. So in the introduction, we see that as the networking is advancing, okay, as the manufacturers of cables are advancing in their manufacturing of cable, they have come up with fiber optic system. Okay, a fiber optic system that is now in front line of telecommunication networking. Okay, the optical networking is now in forefront of the system of cabling for telecommunication. So they are being used extensively for both the private businesses, private networks, and even commercial data links, and also even in government agencies and government parastatals. So they use this optical fiber. We're moving towards the optical fiber. We're going to talk about the advantages that is associated with optical fiber, why the big corporations nowadays, the big agencies, the big businesses, the private businesses, and the commercial data links have decided to replace the copper cable, the coaxial cable, the twisted copper cable with optical fiber cables. Okay, optical fiber wires. So the latest networking technology it can benefit from the development of optical networking, then the speed of network transmission is already of Ethernet. It's already in the gigabit Ethernet, and the 10 gigabit Ethernet already have. Now we are beginning to even have hundreds of 100 gigabits of Ethernet. So this high super speed Ethernet, we benefit from the optical fiber introduction, right? Because light is the fastest thing on earth as we know it. Light is the fastest, and optical fibers are made with light. The signal travels in form of light wave, in form of light pulses. So, and it means anything you transmit with optical fiber generally has higher speed. So if we be able to develop super gigabit Ethernet, then what we match it absolutely will be an optical fiber cabling. Okay, an optical fiber cabling will be a super match for the super Ethernet that we have developed, super speed Ethernet that we have developed. Okay, what we had before for coaxial, we were good for the megabit per second speed, but now that we are in the era of gigabit per second, okay, we are in the G generations, we are in the era of gigabit per second, then a good match for a good speed is the introduction of the physical layer called the optical fiber. Okay, now let's move on quickly. Now, still on the introduction, first let's talk about what is this optical fiber. What is it? What's the difference between this and what we have before? An optical fiber transmission strand can carry the signal in the form of a modulated light beam. So what this means is that the transmission optical fiber transmission wire carries signal in form of light, beam of light. A single one light is called a ray of light. A single light is called a ray of light. But a modulated light or superimposed lights put a rays of light put together become beams of light. So one strand of optical fiber has a lot of rays of light that are multiplexed together to be a beam of light, which can carry as huge data as possible. They can carry huge data as big as possible. Now, few feet or even hundreds or thousands of miles, this signal can be transmitted. Okay, the signal can be transmitted to few feet or even hundreds of miles or even thousands of miles. Remember, like we said, light can travel from Malaysia to Egypt within few seconds, right? Light can travel in just seconds. Light can travel from Malaysia to United States within few seconds. Light can travel from anywhere in the world to any other part of the world, extreme end of the world, east of the world to the west of the world, within few seconds. Light can travel from the north of the world to the south of the world within few seconds, right? So we already know this from our A-level physics, right? We've known this in our A-level physics. So optical fiber is also good for long distance transmission because it can go a long range without attenuation. The signal can go a very long way without attenuation. Remember, attenuation is the degradation of the strength of the signal, as we have explained in previous lectures. Is the degradation, the reduction, gradual reduction of the strength of the signal. So we're saying the use of optical fiber cable enables the signal to be transmitted over a wide range without dropping in strength, without the signal losing its value. Okay, so this is one of the unarguable beauty of using optical fiber in transmission today, in telecommunication today. That's why when you just say hello to someone almost simultaneously, no matter anywhere in the world the person is on your mobile phone, you just call the person, you dial the number, and the person picks up the number. The moment you say hello, simultaneously he's hearing you and he's responding and you are hearing him, because these signals are being transmitted over an optical fiber cable, which are sent from the from your mobile phone, converted to waveform to the next BS, your transmission, your base station transmission point, and then from there they go through optical fiber, sent to the antenna, converted or modulated into a wave, and then sent to this other country on the other extreme end of the world, and then it will be received by the telecommunication system in that country, and then they will demodulate and send it through the optical fiber, and then send it to you, and your phone has the ability to reconvert the electrical signal with which the photo light message was converted to, in the first case, has the ability to send it back into from the electrical signal into a message, a codable message that was even encoded in the first place. So this is the beauty, and this happens in microseconds. All this theory that I just mentioned, they are happening in microseconds. The beauty of light. Like I said, in this dunya, on this earth, on this mother earth, in science, in physics, in engineering, there's nothing as fast as light. There's nothing. Maybe in the future we might research to find out there's something faster, but at the moment there is no particle, there is no energy faster than light. Light is the fastest thing that we know of today that is created by Almighty God. Light is the fastest thing, phenomenal, the fastest phenomenal that so transmitting signal using the concept of light unarguably becomes a genius idea, becomes an idea that is second to none, or that is first to none. You get it? So this is the reason why optical fiber transmission is a beauty. Now let's go to another part of the introductory section of this course, which is the source of the invisible infrared. The source of the light are usually from for optical fiber are usually from LED, light emitting diodes. Not only LED, also from solid state physics. You've studied solid state physics or solid state electronics. So if you study solid state electronics in Department of Electronic and Communication Engineering, or Electrical and Electronics and Computer Engineering, then solid state laser is an example of a solid state device. So the solid state laser naturally is a light source. It's a light source. It gives out light impulses, right? Light pulses, which can travel as it were. Remember, light itself is divided into two sources. We have the luminous light sources and the non-luminous light sources. The luminous light sources are those sources that can generate their own light. Those sources like the sun. The sun is the biggest luminous light source, can generate its own light. Then the non-luminous light source, like the moon does not generate its own light. It only reflects lights that it gets from the sun. The mirror does not have its own light. It's only reflecting the light it gets from another source. Okay, but luminous light source like the sun, like your lambda in Africa, sometimes we use lambda, and not only in Africa, in third world nations, we use the lambda to make our light, right?
in the absence of electricity, we use the lambda. So lambda itself is a luminous light source. It gives out its own light without reflecting light from another source. It gives out its own light. The laser, it's a luminous source. Okay, is a luminous source. The candle is a luminous source. Any object that can gives its own light is a luminous source. Then the non-luminous, I've talked about them. The objects that do not have their own light, they only reflect the light from other sources, like the moon. The moon does not produce. The moonlight that you use at night doesn't produce its own light. It's only reflecting the light that it gets from the sun. So electronically, we concentrate on looking at those small things that we use in our electronics, in our transmission, in our telecommunication, that gives their own light, or that becomes light sources. A good example is LED, light emitting diodes, or a solid state laser. The solid state laser and this light emitting diode, the light from there can be modulated to impress digital data. You can modulate it and convert this to digital data, or even to an analog signal on the light beam. Okay, so this is the second phase of our introductory. Now let's take a look at, after you've identified the light source that you want to use for your light, the next thing is this light has to go into something before it goes into the optical fiber. A good example of such thing that connect the source of the light to the optical fiber is called a photosensitive detector. A photosensitive detector to convert the optical signal back into an electrical signal at the receiver. Okay, a photosensitive detector, actually what it does is to convert the light already. Photo means light. Photo, photo. Okay, photo means light. So if photosensitive detector means is a sensitive detector that can detect light. So this device converts the optical signal. The optical signal is a light wave. Okay, and it converts it back into electrical signal at the reception end. Beside this photosensitive detector is placed at the receiving end, not at the transmitting end, because it detects the light that is coming from the optical fiber cable and reconvert it back to electrical signal. Now, but the one when you're transmitting, the sensor you need to from your source of light into your optical fiber, what you need, it's a light source to cable interface. Okay, an efficient optical connector, a connector at the light source to optical cable interface. And then on the other end, you need a cable to photo detector interface. So there are two interfaces you need. From the light source into the optical fiber cable, you need the optical connector at the light source to the cable interface, the optical fiber cable interface. You need one sensor there. And then at the other end, in the receiving end, you need the cable to photo detector interface. Now these two connectors are very critical when slicing the optical cable due to excessive loss that can occur at the connection. So you have to be careful when you are using this, and they have to synchronize with these detectors. These detectors are both the source end and the reception end. These two detectors have to synchronize with the optical fiber cable. Okay, now let's go on to the advantages of fiber. Why suddenly the fiber use of fiber optics is becoming super popular, and we're finding super use for this. Now, what advantage, what benefit this has over the normal coaxial cable or the twisted pair cabling? Now, number one advantage of optical fiber transmission cable is that they are extremely wide system bandwidth. They give very huge system bandwidth. Remember that one of the desirable characteristics of a network is to have a large bandwidth. because the bigger the bandwidth, the more signal you can transmit at every point in time. The more signal you can transmit at every point in time. Okay, the slower, the faster your system will be, right? So we are always looking for a large bandwidth to transmit our signal through. So this ingenious ability of optical fiber cable gives it a preference, a preferential advantage over the coaxial or the twisted pair cable, right? So why does this happen? Has to be like this. It happens because light wave has the upside amplitude and the downside amplitude, so it's going up and down as a wave as it transmits the signal over the cable. So the amount of information multiplexed on such system is in hundreds of gigabits. So you can multiplex. We study multiplexing in 200 level. We've done multiplexing. Multiplexing is a process of putting more of your channel, of your transmission channel, into one. Okay, a way by which you can take many strands and make them like one strand. Many signal coming from different sources to be able to pass only one channel. So meaning you've multiplexed it. So these characteristics is being done with optical fiber. You can multiplex the signal, the signal that is coming into just one source, and they can go to one source, and it can handle hundreds of gigabit per second speed. So this is a huge advantage, and it's considered a notable one for one of the reasons why people prefer the optical fiber to number coaxial cable. Another reason or another benefit of optical fiber is that it has immunity to electrostatic interference. Is immune to electrostatic interference. Only the cable, only the optical fiber cable, not the metallic cable components that you connect, like your connector, the photo detector connector, not those one. We're talking about this immunity is within the optical fiber cabling. This immunity is within the optical fiber. So external noise, external electrical noise and lightning do not affect energy in optical fiber. That's why we say it has immunity to electrostatic interference. Every other interference coming, electrical interference coming within from the background, this optical fiber cable has immunity against it. Okay, so because of that, it's a huge advantage. It's a huge advantage compared to the coaxial cable. Remember, coaxial cable has crosstalk interference and so many other attenuation issues, but this one has immunity to electrostatic interference. Then number 3 advantage is elimination of crosstalk. You see, in optical fiber, crosstalk is eliminated completely because it has huge immunity to electrostatic interference. Number 2 advantage also becomes a reason for the 3rd advantage. The light in one glass fiber does not interfere with the light with another fiber, nor is it susceptible to the light on the adjacent fiber. They do not crosstalk. They do not interfere with one another. They do not, because light, they are totally eternally reflected every time it passes through a strand of the cable. Every time it passes through a strand of the cable, it hits the end. The whole light, none goes out of that strand of a cable. Let's say there are 8 small wire cable put in one. The light in one cannot crosstalk with the light in the other one. Why? Because when it travels and hit the end, the signal becomes totally eternally reflected back into that strand of a cable, and then hits the extreme end again on the down part. It becomes totally eternally reflected upward again. Then it hit the upper end, it becomes totally eternally reflected downward. So it's guided. It's super guided. It's not allowed. The light is never allowed to go out of that complexity. It's never allowed to go out of that cable. So that's the So it eliminates crosstalk with this advantage. So since crosstalk is eliminated, because crosstalk is coming from where? Electromagnetic coupling. There is no electromagnetic interference happening to optical fiber cabling. So this becomes a huge advantage as the case is, right? Now let's go to the fourth advantage: lower signal attenuation than other propagation system. Yes, the signal is not lost or degraded over a long period. Little, very tiny, something infinitesimal, so you can say. For example, in a length of as long as 100 feet, you just have 0.03 decibel attenuation per every 100 feet. Compared to when you use coaxial cable, you get 4.0 decibel per just 100 feet. You can see 0.03 compared to 4 decibel. It is a huge engineering number. It's a huge engineering number. Okay, so this is the beauty of using. There is very low signal attenuation happening to signal that is transmitted over optical fiber cable. Now let's go to the fifth advantage: lower cost. The fiber cable, the cost is continuing to decline now. Unlike when it newly started, they were very expensive then. But now the price of installation of optical fiber cable continues day and night, continue to decline. The price continue to go down. Just like, for example, when the solar energy newly came out, it was very expensive to install a solar energy in your homes. But now the price is going down as more and more people get on board with this. The price continues to decline. So the decline is accelerating. If we use that physics terminology or the engineering terminology, the decline is accelerating, meaning it's on fast decline. When I use the terminology, the decline is accelerating. That means the price is reducing very fast, super fast. Okay, so lower cost has also made it an advantage, has given it a privilege. Because if it's super expensive, even if no matter how beautiful it is, no matter how effective it is, no matter how good it is, we still cannot afford it. The fact remains that small businesses cannot afford it, or homes cannot afford it because it's super expensive. But right now, the prices are super going down. In Malaysia today, the TM Malaysia, Telecom Malaysia, they super replaced all the coaxial cable with optical fiber cable. So replaced completely the TM. That's why you see some years ago they were digging the whole roads, they were busting the road and relaying optical fiber cable across the entire country, Malaysia. And so also first world country. They've replaced the coaxial telecommunication cable on the ground, because most of these cable are on the ground. You just drive on the road, you don't know electrical cable, some of them are on the ground. So they've replaced them with optical fiber cable. Some of them are buried under the sea. They're buried under the sea. So, and they've been replaced. This coaxial cable be replaced because telecommunications are yearning for super speed to carry super speed data. Okay, another advantage is safety that optical fiber cable provides. In many wire systems, the potential hazard of short circuit they normally happen with coaxial cable, but in optical fiber cable there's a precautionary design that was put in place to eliminate hazard effects. Like, for example, the dielectric nature of the optical fiber completely eliminates spark hazards that are found in coaxial cable or twisted pair cable. So this is a unique advantage. Safety. You're not going to get shocked even if the cable is connected. You're not going to get electrical hazard, electrical shock from this, or sparks from fiber cable. Okay, there another super beautiful advantage is the corrosion. Okay, because it is made from glass. Glass does not corrode, right? Does not rust. So because it's made from glass and glass is inert, then the corrosion effects of Certain environments are not a problem at all when you are using optical fiber cabling. Then the eighth advantage is security. Security, this is due to the immunity to and from electromagnetic coupling and radiations that are found in when you're using the twisted pair cabling or when you're using the quasar cabling. An optical fiber can be used in most secured environment, although it can be intercepted or tapped. It is very difficult to do so, however. Okay, so it's super secure because there's no electromagnetic crosstalk, there's no crosstalk happening, so it's super secure. So these are the advantages of this optical fiber cabling. Now let's, like I said, we will now have a review of the rest part of this chapter. We finished the introductory part. So what we've done is 3.0. What we simply done is 3.0, 3.1. Now what we have now, the 3.1 examines the issue of optical networking, and then the 3.2 presents an overview of optical fiber fundamentals. That's what we're going to learn in chapter 3 part 2. Chapter 3 part 4 part 3, we examine the two distance limiting parameters in optical fiber transmission, and we look at the effect of attenuation and dispersion. These are the two parameters that we're going to look at in chapter 3 part 3. Chapter 3 part 4 includes an overview of LEDs and lasers. That's the sources of the optical fiber lights. Okay, the lights, the source of light for optical fiber transmission. So the LEDs and the lasers and the components used in a long haul fiber network and the various type of connectors currently used in the fiber. So we go to in part 4. Now part 5, we look at the optical networking itself. Okay, optical networking will be looked at in chapter 3 part 5. An overview of the SONET. SONET will be presented in chapter 3 part 5, and it will be followed by the optical Ethernet. Okay, and it will include a discussion on setting up, how to set up buildings and campus distribution for optical fiber. That's what we're going to do in chapter 3 part 5. In chapter 3 part 6, we're going to look at safety, because safety is extremely important in engineering. So we're going to have an overview of safety in chapter 3 part 6. Then chapter 3 part 7, we're going to look at the OTD arrow will be holistically there too. So this is the end of this first section, and thank you for listening to us. You're welcome again, once again, to our class in Waidsum University, number 1 and the fastest growing technological university and digital university worldwide. Thank you.